Hello, math students. Welcome back to Module 10, Percents and Proportional Relationships. The title of today's lesson is Percent Error Problems, and this is lesson 8. I apologize. That was me not reading it correctly. Lesson 8, Percent Error Problems. Our goal for today we will learn how to determine percent of error in a problem. Percent of error, because there's a lot of times we as mathematicians make errors, and so sometimes there are statisticians out there. Those are people who study data. They like to figure out the percent of error. So how often is there an error? How often is there an error in counting votes? How often is there an error in figuring out race times? That kind of stuff. So the question I want you to think about during this lesson is, when would we need to find the percent of error? All right, things to know, and this is kind of important. Percent error helps people understand what an error can do to a situation. Percent error can be easily calculated if you have the exact information that you need. There are two parts you must have to determine percent error, and they are, that was a typo, Mrs. Nelson, they are the exact value and the approximate value. Okay, the exact value is the real thing. The approximate value is what you think it could be. Okay, the exact value is the real amount. The approximate value is the guessed amount. That's another good way to think about it. The real amount versus the guessed amount. To find percent error, you must calculate the absolute error by dividing it by the exact value and then multiplying it by 100. Okay, and so I showed you mathematically what that looks like. So it says to find percent error, you must calculate the absolute error. So that means you're taking the approximate, subtracting the exact. Okay, what do you do first? Approximate minus the exact. Then you have to take the absolute value of it. Okay. And then you are going to divide that by the absolute value of the exact and then multiply by 100. Okay, so writing that out to describe what this is gets a little bit confusing, but when you look at it and read it, okay, I take the approximate minus the exact and then take the absolute value and then I divide it by the absolute value of the exact and then times it by 100. Okay, and that's how you would do that. All right, so we're going to practice it to make sure that you've got it. Mrs. Nelson is hoping to have 12 people come to her house for a party. 25 people actually came. What is the absolute error? What is the percent error? Okay, holy moly, that's kind of a big deal. I was only thinking 12 would show up and 25 came. So that is a giant percent of error, I think. Okay, first thing, step 1, identify the parts. The exact value was what? She was hoping to have 12, but actually 25 came. So what is the exact value? If you're thinking 25, you're correct, because that's the exact amount that actually showed up. What did I think was going to show up, or what was I hoping for? The approximate value I was hoping for was 12. All right, so now the next step, step 2, says to determine the absolute error. So remember, to find the absolute error, you take the approximate and subtract the exact. And some of you are going, you can't do that. Yes, you can, because we know how to work with integers. So our approximate value is 12 minus 25. Now you understand why we have to have the absolutes. Okay, well, 12 minus 25 is actually a negative 13. I hope all of you remember that. Now that I've figured out negative 13, I'm going to take the absolute value. Absolute value tells you how many hops from 0 is, so think on the number line. Where is 0? Where is negative 13? How many hops did it take to get to 0 from negative 13? If you said 13, then you have remembered how to find absolute value. So this right here is the absolute error, so we're calling absolute error of 13. Okay? Then it says the next step, and I'm sorry for having to go on to the next page, but we have to because we ran out of room, so I'll try to put this right here so we can still see what we're doing. Step 3 says determine the percent of error. So I already know that the numerator is 13, Then it says that I'm supposed to divide it by the absolute value. The exact value, x is the exact value, a is the approximate. So I'm going to divide it by 25. Ooh, this one's easy because this one goes to 100. So I can take that to 100, right? So this, an equivalent amount to this would be that, right? Yes or no? Does everybody see it? How did I get there? Times 4. What you do to one side, you have to do to the other. So 4 times 3 is 12. Regroup. 4 times 1 is 4, plus 1 is 5. So now, what percent do I have? 52%. Okay, so what was the percent error? The percent error is 52%. If that's 52%, that's over half of an error. So would you call that a large error or a small error? I'm talking large error. That's over half of the miscalculation. If it was like a 7%, I would say it was small. But if it's over half of an error, I would call that a large. Okay? Do you understand the process of how we did that? So let's go back and review. Step 1, identify the parts. The exact is the x. Maybe I should write that in there. This is the x, right? This is the a, right? So the exact value was 25. That's who showed up. The approximate value was 12. That's who I was hoping for. Then you take the hope or the approximate and subtract the exact, which gave us negative 13. Then we had to take the absolute value, which is the distance from 0, so that's 13 hops. So 13 is this guy up here, and then I had to divide it by the absolute value of the exact, which was 25, and then I said to myself, okay, 13 divided by 25 is actually equal to 52 hundredths. Does everybody understand? If you used a calculator and you did 13 divided by 25, you'd get 0.52. Then you'd multiply that by 100 and you would get 52%. Okay? And then you have to decide, is your percent error large or small? Okay? So it's kind of fun if you follow everything that you're supposed to do. All right, so the next one, I'm actually going to make you do it by yourself, but I want to go over the steps to remind you how it works. So try this one. At a winter dance, the student council anticipated 450 students. 510 students actually came to the dance. What is the absolute error? What is the percent error? Okay, so let's go back. First step is identify the parts. The exact value was 510. The approximate value was 450. Then you're going to take it through this whole process. Remember, the absolute error is this when you're subtracting. So back up here on this question, when it says what is the absolute error, you're going to say it was 13. And then what is the percent error? It was 52%. So that's how we identify those two answers too. I'm sorry, I forgot to go over that. But you're going to do the same thing for the dance. All right? So really not difficult as long as you remember the steps. So let's go back to our goal. Today we will learn how to determine percent of error in a problem, which is what we did, as long as you remember to use approximate minus exact, then take the absolute value, then divide it by the absolute value of the exact, and then multiply by 100 to get your percent. Okay? When would we need to find the percent of error? I actually told you a couple, so hopefully you remember those and you can answer that question. All right, kiddos, that's all I have for you today. I'll talk to you soon. Bye.